as my video tries to figure out if the lights are on or off. Good morning. We are live. As you can tell, I've got all my various colored pens. I have a pencil because we might be doing some sketches, so you may want a pencil. And I have a ruler because we're going to be drawing a lot of lines, and I want to make sure that they look straight, even if they're not like straight, like horizontally or straight vertically. Okay, so they can be slanted. They're still considered straight, even though they're all slanty. All right?
Yeah.
All right, here we go. The first word that we need, the first thing we need to talk about is the word transversal. So over here in my left-hand margin, I'm going to write transversal because that's my first big vocabulary word to go over. Stop. Shh. Calm down. We're recording. Calm down. All right, so I need to draw a few lines. So I'm going to draw 3 lines. I'm going to draw them all crooked because it doesn't matter, but the important one is this one right here. I want to make sure that this one that I made extra super bold and big is crossing at least 2 other lines. Okay, and I'm going to make it clear that these guys are lines by putting those arrows. Yes, sir. There's no ruler in that toolbox. I'm very sorry.
I'm just warning you.
Okay, I will show you where to get rulers later. So, this line right here is the transversal. That line right there. It's the line that intersects at least 2 other lines. And special special angles are formed when you have this sort of relationship happen. And I'll give you the names. Those names can be found and the explanations can be found on that 3.1 video. But we'll talk about those and you'll see those in action today. Today. Thing I want to show you is right in here. If I cover up, I'm going to use some of these attendance slips that I have sitting around here. If I cover up everything but that, what do we see sitting right there?
A line, a ray.
A line, 2 angles. 2 angles that are forming a line.
Yes.
If we put them together, what do we call that? 2 angles that end up forming a straight line.
Perpendicular. Straight.
Close. We have 2 angles that their non-shared sides form a straight line. Bisector happens when it gets cut in half. I like where you're going with it. Perpendicular happens when they hit it at a 90-degree angle. All of this could happen, though. So you're not wrong, in a way, because it could happen. It's just we have no guarantee that it's happening right now. So we have to find a way to discuss it in general. This was way back, like week 1, week 2. What do we call these pairs of angles? That their non-shared sides form a straight line. Collinear, on the same line, so you're kind of halfway there. I especially like that word linear in it. Collinear planes. Planes are bigger than lines, so it's hard for a plane to be on the same line. And these aren't planes, these are angles, which live on planes, I agree, but we're zoomed in a little bit more. What were you saying, sir? A ray. It definitely has rays. From like this point this way is a ray. Definitely has rays. And look, we have opposite rays, right? They start at this one point and they go in opposite directions to make a line. So you have some opposite rays. Shut up. She's teaching. And we're recording. As soon as I say the name, you guys are going to groan and be like, we knew that. You ready for that moment? They're called a linear pair. So if you remember, give me an oh yeah.
Oh
Yeah. All right. What if I did this? What do we see happening right there?
They're at the midpoint.
They're crossing. Do we have more of those linear pairs?
Yeah, no, yes.
Yes.
The other two that they're going to.
Right here
Yep.
and right here. What do we know about linear pairs? About their angle measures.
Oh, they're acute.
Some might be acute.
No, they might be the same.
Some might be obtuse.
Some might be right.
Some might be right. All of you are
They
correct.
all go to 180
In a way, okay, give me more. I like that you're saying they all do something to 180. Give me more.
when the angles are added together, they all equal 180 because they're all straight.
Beautiful. When this angle's added to this angle, you get 180 because you have this straight line sitting there. Lovely. What do we call that relationship?
No, that's fine.
180-degree line.
Started with an S.
Straight?
Straight line. Yeah, straight angle. We have another special name for it.
Straight angle.
SU. Say it louder.
Substitute.
We're really close. No, we're really close. We're really close. I like your, because that was a word that SU something. So SUP. SUP.
Sopita huevo.
Say it again. Supplement.
Supplementary line.
This is the supplement to this, and so they are supplementary angles. You're both correct. Nicely done. So take a side note, take a moment and jot down right here. And remind yourself, linear pairs, angles that together form a straight line, add up to 180. They're supplementary. You write whatever you need to write to remind yourself of that.
So I
They
was,
add up to 180.
I was close, right?
You were really close. Because there's some substitution that happens because you're right. Okay, I'm going to look into here. Okay, you wrote it somewhere over here, wherever you have space. Okay? I'm going to number these angles. 1, 2, 3, 4, 5, 6. Thank you. And I'm going to want you, please, to find the measure of angle. Remember, this little M means measure of, and this weird, funky fell over V means angle. Find the measure of angle 1. And the only thing I'm going to tell you is that the measure of angle 2 is 60 degrees.
That's too easy.
It's too easy?
That's too easy.
It's
Too
too
easy for
easy.
I can do
Travis.
that in my head.
In your head, okay, what are you doing in your brain meat?
No, he's not.
Okay, since angle 1 and 2 are supplementary angles, you can subtract 60 from 180, and it gives you 1, which equals 120, which equals to an obtuse angle, which that is an obtuse angle, so that makes sense. I am positive about that. Thank you very much. It's 120 degrees.
It's beautiful. I don't think I could have said it better. Let me rephrase. I'm going to basically repeat what he said so y'all can hear it again. Because angle 1 and angle 2 are a linear pair,
Yeah.
they are supplementary. Their measures add to 180.
Correct.
Therefore, since angle 2 measures 60, 180 minus 60 is 120. That must be the measure of angle 1.
Correct.
Which, if you wrote exactly those words in a paragraph, that's a perfect paragraph proof. So I want you, please, right now at this time, to write the paragraph proof of the measure of angle 1, which is exactly what we had just said. Write the paragraph proof for the measure of angle 1. All right. I'll repeat it again. Is that okay? Okay. But I'm not going to go super slow. I'm going to just kind of go over it quickly. Angles 1 and 2 form a linear pair. Linear pairs, by definition, are supplementary. Therefore, 180 degrees minus 60 degrees, which is the measure of angle 2, given, leaves you with the measure of angle 1, which is 120 degrees. So you want your paragraph to read something like that. It's okay.
It's okay.
It's okay.
You just broke it.
All right, take a few seconds. Take a few seconds.
What did you call them? Linear what?
Linear pair. Linear pair, yes. Thumbs up when you're done with your paragraph proof, please. Thank you. Thank you. Thank you, thank you. Thank you, thank you. Thank you. Thank you.
Wait.
Okay. Give yourselves a few more seconds. Okay. Thank you. Notice the New York directions, the New York directions? I will learn to speak this Monday morning. The new directions read, find the measure of angle 3. Did you find angle 3?
Oh, angle 3?
Yes.
Sure. It's 120 as well.
Why is it 120 as well?
Because, well, there's two ways you can look at this.
Okay.
Angle 2 and 3 are linear pair as well.
Angle 2 and 3, also a linear pair. And so if I asked for a proof for this, you would give me something similar to angle 1's proof.
Exactly.
Yes, ma'am.
Okay?
And since there's another way to look at it, angle 1 and 3 are opposite angles, I guess, for example. So
Okay. They're directly across from each other?
exactly. I don't know what the word would be for that.
Okay, vertical angles.
Vertical angles, so therefore they are equal.
All right. Okay.
I don't know how to word it.
No, you worded it perfectly. You worded it perfectly. The only thing I had to give you was vertical angles. It's worded perfectly.
And angle 4 is 60 degrees.
Okay. You're nodding. Made sense? Okay. Yum. Or was it good? You liked his explanation? What do you think? What do you think? Did you hear his explanation? Yeah, you in the corner. Yes, you in the corner. Did you like his explanation? Did it make sense? Okay, we already wrote it as a paragraph proof. So now we're going to write it as a 2-column proof. As a 2-column proof. And you guys are looking at me like, what in the world is a 2-column proof?
Wasn't that in the video, miss?
You didn't even watch it.
The 2-column proof is something that you are very, very familiar with already. Look familiar? Two-column proof has statements and reasons. Does that look familiar?
Yes.
All right. So what's our first statement? Always start with the most basic. Always start with what's given. What's our first statement? What was it? Well, huh? Where are we starting?
Agent Juana from the
Hey,
centro.
hey. Focus on this first. We're running over on time. Where are we starting?
From 1.
From 1. We want to start with what's given.
So 260.
The measure of angle 2 is 60. So the measure of angle 2 equals 60 degrees. And by the diagram, what else are we given? We're trying to get to the measure of angle 3. Yes, say it.
We could just
Linear Pair. Yes. Which ones are the linear pair that can help us? Because there's a lot of linear pairs here. So you got to find the one that will help. Angles 1 and 2, are we interested in angle 1 right now?
Oh no. Angles
2 and 4.
2 and 3.
Oh.
Okay. So angle 2 and angle 3 are a linear pair. And we can say that's given because it's in the picture. We were given a diagram. All right. Now that we know that they're a linear pair, what can we say? They're a linear pair. What do we know about their measures? So we know they're a linear pair. What do we know about their measures? What do we know?
Miss, I think if you just put 2 and 4, aren't they the same?
Yeah, 2 and 4 are going to be the same measure. Yeah.
Oh, 60.
We were trying to find angle 3.
Oh,
If I had asked for angle 4, you were totally right.
yes!
But she did it.
But I didn't in this case. But I could have.
Are you gonna ask?
Maybe.
Can you?
Maybe. Help me find angle 3 first. I know they're a linear pair. Now what?
Oh, they
From your paragraph proof, what did you say after they were a linear pair?
They have to add up to
Hey, see when you guys-
180
Why?
Or no?
because it's a line.
What was that? What did we call that?
Supplementary.
Supplementary. So our next line says that angle 2 and angle 3 are supplementary. I can't fit it all on one line, so I'm going to have to put a hyphen. And this is the definition of linear pair. You see how this is kind of like the sentences, sort of, from your paragraph proof that you wrote once the line before? Our first sentence was angles 1 and 2, in that case, are a linear pair. And because they're a linear pair, they're supplementary. Right? That was our first couple sentences from our first proof. Same sort of thing happening here. All right, because they're supplementary, we know that their measures add up to what?
180.
So that's the next line to write. The measure of angle 2 plus the measure of angle 3 equals 180. And this is the definition of supplementary angles. Is this feeling familiar from all of our algebra connections?
Yes, ma'am.
Good. Not hard right now?
No, ma'am.
Good. All right, we know the measure of angle 2, don't we? It's 60, so what property could we use to get that in there to work with numbers? I know the measure of angle 2.
Miss, can you repeat the question?
I know the measure of angle 2. And I want to replace it in here so that way I can try to solve for this measure of angle 3 business.
You should have been
60.
What property allows me to do this?
Substitution.
Substitution property. So by the substitution property, I can write 60 plus the measure of angle 3 equals 180. Looks a lot like algebra now?
Yes, ma'am.
It was just this first part that looked kind of weird, right? Hopefully not too weird.
Minus 60, minus 60.
Minus 60, minus 60, what is that called?
I don't know.
Inverse operation, and what property allows you to do that inverse operation, which is the minus 50?
Subtraction.
Put it all together, what property?
Subtraction problem.
Say it. No, subtraction. What you said before.
Subtraction.
Subtraction what?
Subtraction.
Property.
Property.
There you go. You're right. I wanted him to say it too,
Yes.
so he could get
I
it.
am the smartest in the class.
Oh, you're not.
Oh, don't be mean.
Oh. That's
Miss.
funny.
Don't be mean.
Miss
just made me want to drop out.
Are you thinking you're being
Stop just
truthful?
being honest.
Oh. Did we get what we wanted?
No.
Which was the measure of angle
ma'am.
3? All right. So if I ask for paragraph proof, could you do it?
Yes, ma'am.
And it's the most challenging. It's going to feel a lot like your English class. It's okay. I'm sorry. I'll help you get better at it, okay? How do you like the two column proof? Yes. All right. Your last example, I want to try to make it way more complicated so that you won't be frightened by anything. Are you ready?
Yes, ma'am.
All right. I'm just going to show it to you, and this will set us up for tomorrow because we're at 8:30. You could totally see something that looks like this. Calm down, calm down.
He feels like he's not ready for this.
It looks really weird.
There's two subs things.
What did we call those?
Supplementary.
Are you looking at the lines or the angles?
The angles.
The angles. Yeah, there's lots of supplementary angles in here and there.
I see a triangle.
You see a triangle? Awesome. Important to know. What other shapes do you see?
Adrian.
A trapezoidy thing.
I see an R for Robert.
You see an R for Robert.
I see an acute angle.
There's some acute angles.
Oh, I
I see a
know.
right angle.
I think I see a
Two
right angle.
angles?
I think I see
There's
two
no
right
right.
angles.
Maybe some right angles.
If I hear acute angles, I know there's
Can you not, Robert?
What the thing?
Okay. I love all of this. Here we go. Gonna start labeling angles. Calm down, calm down.
Sorry, man.
Calm down. Oh my goodness. There are so many angles.
Miss, can you not?
Holy cow. I tried really hard on this one apparently.
Oh my lord.
Welcome to college.
Wow, well, welcome to college. Here's your college level question.
Find the radius.
You might see something like this on ACT or SAT. And they'll go find the measure of angle 4 if the measure of angle 1 equals 100 degrees. All right, go.
Miss, do not help us, please.
I'm not going to help you.
Give us 10 minutes.
Oh, the 25 minutes.
Give me 20
Find the
minutes.
measure of angle 4 if you're given the measure of angle 1. Can you do it?
Yes.
Do it. Where's angle 1?
Is that an M?
Yeah, this is an M. Yes, the obtuse angle up there. It equals 100 degrees. Where's angle 4?
I got it.
Right there, right next to it. What's the relationship between angle 1 and angle 4?
The linear pair.
They're linear pairs. Yes, both said it about the same time. Which means you add them up and you get? Because they are?
Supplementary.
Supplementary. So if angle 1 is 100, angle 4 must be? 80. Nicely done. Jot it down. Find the measure of angle 11 if the measure of angle 5 equals
21.
92.
That's not even funny.
I got it.
What is it?
100.
It's 100?
No.
It's 100.
Where's the measure? Where's angle 11?
Oh wait, 92.
There. Where's angle 5? What's the relationship? They're not a linear pair because they don't sit on the same straight line. They're across each other. What? They're vertical. What do we know about the measures of vertical angles?
But I like to. I like to.
Starts with a C.
But,
I like that one from Jack in the Box.
These technically are coplanar, you're right, but that doesn't help us with the measure.
they're
They might be. Depends on the picture. What's the relationship between angle 5 and angle 11?
They're opposites.
You said that they were vertical, they were across each other. What do we know about the measures of all vertical angles?
They're the same.
They're the same. What do we call that starts with a C? Con. I heard it. Congruent. Say it louder. Congruent.
Yes.
So if angle 5 is 92, what's angle 11?
92.
There you go.
21.
Tomorrow,
Yes.
we are going to play around with the same concept, and we're going to name the different types of angles we see. Wait. But these lines that the transversal are going to cross are going to be parallel, and we're going to see what happens to those
Oh,
angles.
the right angles.
Go.